Story time with Linz is always a good time. All right, so here we go. All right, so yesterday, if you had me in class, you learned all about the left-hand rule. Okay? So the left-hand rule says that if you take your left hand and you hold it out, your left hand, but now I'm tweaking my left-hand rule, because I think yesterday I said put your thumb down like this. Okay? I'm tweaking it, because then I'm like, wait a second. If your pinky goes straight up and down, then your thumb in the relaxed position goes straight out. Right? So if you tweak your hand just a little bit, now you've got quadrant number 1. Right? So it looks like that. Okay? So you got quadrant number 1 with the 3 angles for your other 3 fingers of quadrant number 1.
Yeah, why didn't Mr. Roth teach us?
He was supposed to yesterday.
He did. Mr. Roth.
Mr. Roth, I tell ya. Okay? Alright? So there you go. Now, for me, okay, so then here's how I remember it. Some people go up and down. They count 1, 2, 3, 4 up and down. Or excuse me, 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4 up and down. How I remember it, and this is me just being cray-cray now, okay? So whatever angle that I'm taking, okay, so if I'm doing like pi over 3 or 60 degrees, that's my ring finger, right? So I take that one out, and then above is cosine, below is sine. So the square root of 1 is 1 over 2 is 1/2. So the cosine up here would be 1/2. Square root of 3, because there's 3 fingers below, would be the square root of 3 over 2. Okay? Left hand rule. Okay? Now, the kicker with that is, so that works for pi over 3. But that also works if I reflect that point into quadrant number 2. That works for 2 pi over 3. If I reflect that point into quadrant number 3, excuse me, that would work for 4 pi over 3 and 5 pi over 3 in quadrant number 4. Okay? The difference with those points, depending upon which quadrant you're in, is the fact that you got to think back to when you first learned about your quadrants. And the fact that this quadrant is positive, positive. This one is, oops, I almost put negative, positive. It's,
Back or redo. Undo.
I know, but I got to walk all the way over here. Forgot to choose the small one. Negative, positive there. Negative, negative here. And positive, negative there. Okay? So depending on which quadrant you're in, that's going to adjust that. Okay? Same thing here goes for pi over 6. Except pi over 6 would be paired with 5 pi over 6 in quadrant 2, 7 pi over 6 in quadrant 3, and 11 pi over 6 in quadrant number 4. Left-hand rule tells me now I've got 3 fingers above my gap, so that's going to be the square root of 3 over 2 and 1/2. This one is going to be pi over, oops, I already used purple. Tap the brakes, Lenzmeyer, you already used purple. It's like literally right there. Can't use purple. We'll use green. Green works. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that one's going to be root 2 over 2, root 2 over 2. And hopefully you just flat out remember that your thumb is 1, 0 and your pinky is 0, 1. Okay? With that being said, what we're going to do today now is we're going to do, what is it? trig values worksheet. Okay, so I'm going to say, what's the sign at pi over 6? Well, sign, if memory serves me correct, is the y value. Correct. So the y value here then would be, at pi over 6, would be 1/2. Because it's in quadrant number 1, y value is positive in quadrant number 1. Okay. Sine of 11 pi over 6, well, 11 pi over 6, now that's still on the blue ones, right? Except which quadrant is it in? 4. So that means my y value is negative. So that would be negative 1/2. Cosine at pi over 4 is root 2 over 2. Cosine at 5 pi over 4. That's which quadrant? 3. So cosine is negative in quadrant number 3. So it's negative root 2 over 2. With me? Love it. Just when you thought it was nice and easy and that things were all peachy keen, what do? I go and I change the questions. Okay? Try those 3. Now, I know that in all of your notes, there's a complete unit circle, at least one of them, right? Some people have already started making a second one. Start making a second one? Practicing?
This one.
Right. Yeah, but you know what I mean? You gotta practice, because next Tuesday, I shouldn't say next Tuesday, the Tuesday after Thanksgiving, you got your memorization quiz. Okay? So I understand that you have a copy of the unit circle. And that's great. For your homework, for your notes, that's great to use. Okay? But on a test or on a quiz, you won't be able to use that, and we are not going to give you one. Okay? Say that again. You can use the unit circle that you have for your homeworks and for your notes in class and all that fun stuff, but on a test or a quiz, we're going to ask you these questions, and you're not going to have it. Okay? All right, so talk to me. What is cotangent? It's the reciprocal of tangent, right? Okay, easy. Or it's what, Lily? It's x over y. Yep, okay. So we can think about this one of two ways. We could think about this as 1 over the tangent at 3 pi over 2. Or we could think about this as x over y from our, what class was that? Wednesday. Okay? All right. So at 3 pi over 2, just a quick mental break here. 3 pi over 2 is down here. Right? So that is going to be at the point 0, comma, negative 1. So this could be, if I do it the x over y method, this could be 0 over negative 1, which simplifies to just be 0. Right? If I did it as 1 over the tangent, then that would have been 1 over, tangent is y over x, so it would have been that. Then I would have had to flippity-floppity. Oops, I should use a different color because, you know, I'm all about the colors. and it still gives me the fact that it's 0. Okay? A couple of different ways of doing that. Cosecant, 3 pi over 4. First off, I'm thinking about where 3 pi over 4 is. And that's over here in quadrant number 2. Right? So cosecant is 1 over the sine of 3 pi over 4, or it's 1 over the y value. Well, at that point, I'm at negative root 2 over 2, root 2 over 2. So 1 over the y value would be 1 over square root 2 over 2. Which would be 2 divided by the square root of 2, which is the square root of 2. Last one's mean? Yeah. Well, you know why it's mean? Guess who really likes these problems?
Mr. Ross?
No.
No.
NTC.
That was my guess.
Yeah. But I like them too. I like them too. Okay? So, what is this? What was this? What is this saying? So you're taking the cosine value at pi over 3 and squaring it, right? Okay. Well, what's the cosine value at pi over 3? It's 1/2, right? Because that's this one up here. Okay, that's ring finger on the left hand. Okay, cosine is above, that's 1/2. So I'm going to take 1/2 here, and I am going to square it. Okay. 1/2 squared is what? 1/4. Secant. What is secant? Reciprocal of cosine, right? 1 over x, right? Okay. So that is going to be then 1 over what is the cosine at 5 pi over 6? Negative square root 3 over 2. And I'm going to square it, right? Well, this is negative 2 over the square root of 3, quantity squared. Negative 2 squared is 4. Square root of 3 squared is 3.
Like simplified it first, though, like before you squared it, because you can't have the root in the.
But that's just dumb.
Yeah, but that's what we've always done. Is that you can't have it in a.
I mean, you can do it that way. You're still gonna it's gonna reduce to 4/3. Yeah, but if you know that you're gonna square it because you read the problem, why simplify it when you're gonna square it and get rid of the radical anyways?
If I reduce it, though, it's negative 2 square root 3. So how would that end up being?
Because when you square it, you get negative 2 squared is 4. Square root of 3 squared is 3, so that's 12 divided by 9. It would be then, because 3 squared would be 9. Okay? Cosecant. What is cosecant? 1 over y or 1 over sine, right? Okay. What is the sine value at 7 pi over 6? Negative 1/2, right? Oops, tap the brakes, Linsmeyer. And I gotta square that. Well, what is 1 divided by negative 1/2? Negative 2. Squared is 4. So, let me bring this one down a little bit. So this is an add. This is a subtract. Adding and subtracting fractions, what do I have to do? Common denominator. I'm thinking 12 plus 12 minus 12. 1/4 is how many twelfths? 3. 4/3 is how many twelfths? 16. 4 is how many twelfths? 48. 3 plus 16 minus 48, negative 29. And all of that is over 12. Yay! Now, in my last class, they gave me negative, I don't know what they gave me, negative 2 and 5/12. Do I like that? No. My apologies to any redheaded stepchildren in the room or listening on the line, but mixed numbers are like the redheaded stepchild of math. Okay? Some people like them, most people don't. Oh, you've never heard that one? Like the redheaded stepchild? Oh, you guys gotta get out more and hear things. Okay? Alright? They also-
Wait, the sun.
Or, yeah.
The thing.
The thing, yeah.
It's been around this earth so
Wow. Okay? They also gave me a decimal approximation there.
That's a no-no.
That's a definite no.
Oh.
Okay? Not happening. Okay? Exactly. Okay? Always give fractions, and improper fractions are the best. So what I'm going to do now is I am going to hand out a worksheet that has more practice problems of this kind. Notice the color that it's on. That means it's homework that's due.